Okay. I think sound is okay. Okay. All right. Welcome back, everybody, to another video about this project. And so we'll pick up from where we left. Um, we'll pick up from where we left on the last video. I think by now, looking at the changelog or what you're going to talk about today, it's very evident that today's video is all about the software. For the few videos which I've been uploading, it's all been about the hardware. What are we going to build next? Or what am I building right now? So this video generally will be talking about the software that controls that hardware, generally the VehicleOS. So for those ones who are new to the video, I'm building an EV from scratch, and so far the designs I've been working on. In fact, I need to upload another video about the designs. And then so right now I'm at the stage where I think I need to start also working on the software in tandem, because there's a lot of work that is going to be required in coming up with all these features. So just a quick rundown. Generally for this video, I'll be talking about building the OS again from scratch. It will be a Linux-based VehicleOS. And I'm going to go through the basic functionality, the advanced features, and the basic functionalities for the OS, the core modules which are going to be required to be built, and generally which approach I've chosen. I think, yeah, which we can put something like this. Yeah. So yeah, my approach for this. The core modules, which components I'm going to select, and generally that's it. So you see, when building an OS or compiling an OS from scratch, you need to, of course, know which hardware you're going to work with. And so at the moment, I've narrowed down to two options. There's going to be testing, and there's going to be the real thing. So for testing and also starting off, I had two options using the NXP S32 G2 and the Raspberry Pi 4. So for now, I'm going to start off with the Raspberry Pi 4, and later on, transition onto the NXP S32 G2, which should be arriving anytime soon. So when you're working with any board, especially when you're using Linux as your starter OS, just working with the Linux kernel, you need to know exactly how this the OS is going to be running on the board that you select. This part. So if you look at this part here, there's a tool called BuildRoot, which generally makes embedded Linux easy. Generally, it's like it helps you create your own custom OS of whichever board that you're going to work with, because it will be possible to just get a desktop Linux and then put it on any board that you have, but you're going to have a lot of unnecessary software which you don't need. So BuildRoot gives you that ability to customize whichever OS you're going to work with. The tools that you're going to be needing are only those ones that you need. Anything else, you don't need, no need to put it there. So to start us off, what I'm going to do right now, because this process takes time, I'm going to start the build process, and as I explained, these other concepts. So by the time we finish, this build process is going to be done again. So so just up here, because let me first remove the one which was work here, so that at least we can know we are working with. So let's see. So let me just remove everything. And that it's a huge file, and I attempted this, and I hope that this time around is going to work, because things happen. So I thought maybe the best way to just do it to start again from scratch. So I put on some code. Okay, so that's gone, and then again, let me just remove these two. That should work, and then yeah. So starting off on a clean directory. So again, we don't need this right now. So that's, at least it makes it much bigger to see. Yeah, that's much better. And then yeah, get the fire back on. So what I'm going to start off with right now is since my target hardware is going to be the Raspberry Pi, so I need to ensure that I have all the tools that I need. So let me get this ready. Something that I should be having here. Okay, that's now sorted out. So the first thing that we're going to do is let me see, get the recent version for build root. So it should be some contribute sponsors, documentation. Nah, we don't need to get that right now. I remember it was supposed to be somewhere in the build directory. Yeah, download stable. I think 2025. Yeah, it should be the stable of. Okay, so let's get a copy of that stable. So we're just going to put in the address. That's build root .org. Then that's downloads, and then I'm going to go with 2025.02.tar.gz, and this is a PGP signature, so we can just get that. So build, let's build root 2025.02.tar.gz. yeah, I think that should be it. This any mistake, I'm sure it's just gonna fail. All right, so downloading that. 404 not found means that there's something wrong. Download. Oh yeah, it's download, not downloads. Checking again. Let's connect to the server again. 44 not found. 2025.02. Sorry guys. Yeah, something I'm missing. 2025.02.tr.gz. That's build root.org. Seems there's something I'm missing. I'll just copy this, copy this link, and then to ensure that we get the correct one, and then insert widget. Yeah, I need to put that. So yeah, that should work. Probably there's something small I was missing there. Okay. So it's successful, and then now we're going to extract the archive store xv zf, and then what we had there, that should get the same thing. So let's go into that directory. So I've got my the main files. So this is what you get when you download a build root. For guys who like me work with Arch Linux, there's a tool called build root meta. I've not used it. Can't use much. It gets the file straight from build root. So thought of maybe just work with this directly. It could be okay. Okay. So now we've got all these things sorted. I know my target device. It's Raspberry Pi 2, so it's an old one, but serves good for testing for right now. So what's going to happen is we should have a build directory here. I think everything checks out. So as per the documentation, you're supposed to run make many-config. This is a common command when you're working with the kernel. So make many-config. So it's trying to build a menu which will assist me in selecting the different properties for the customized Linux which I'm going to be working with. So from here is where you get to select basically what type of options you have. But there's something that come here to target options, something I want to show you first, even before we head there. So you exit from this. No, don't save right now, because already the Raspberry Pi is a known hardware and all the configs are already come built into build root. So what you're going to tell it to be is make list for now the default configurations, default config, make a list for default configs, something should be like there. Can't find make list of default config. Let me see. Probably let me check on the documentation. Should be it's a HTML slightly. This is quite fast to get it straight from the many config, and then that one is known. List default config should it be a not, maybe there should be not, no, def config. Let me see whether I could find it from history. Should be much easier. Like yeah, probably. I think it should be make list default. Make probably no. And def make list should be if config. Not able to make target. Let me just check here. Should be vim make file. Let me see. Should I should check somewhere here. List of configs. So configs. So yeah, I think I had it right. So it was just list. Yes. So from this list, let me see whether we could get this back. So from this list, you quickly check up here. This is my configuration. So Raspberry Pi 2 dev config. That's for build for the Raspberry Pi 2. So Raspberry Pi 2 underscore dev config. So make Raspberry Pi Pi 2 underscore dev config. So configuration written to yeah, so that should be okay. Build root, all that, 5 config, and then make all. So I think that should be all. But you can see there are other custom boards which I'd love to give a try to. There is a STM32 F2429 Disco. Come across this board before, and a couple of them are listed here. So yeah, we're gonna have an interesting build time when we get that board. But you can see the build process has started. So I'm going to push that to the side because that will take time. That will take time. So I hope by the time I finish this video, we'll have all this finished. So seems there was a problem here with power. So let's get this one done. All right. So the build process is running very well. I think now it's time. Let me just explain this concept. So I hope my voice is heard despite the music. So let me just take it down to 25. So when I was talking about a VehicleOS, in the market already we have quite a number. There's Automotive Grid Linux, NVIDIA Drive OS, Huawei, Harmony OS, and QNX. QNX is a consortium between different OEMs who have come together to have their own generally OS. I've worked with AGL before in the previous project, but I've not touched NVIDIA Drive and Huawei. So this is the Chinese company that makes beautiful vehicle. So let me just clear this list right now. So MPV. Yeah. So basic functionality. So when talking about a VehicleOS, there is battery management. That's the basic functionality, motor drive control, and infotainment. When you come to advanced features, ADS, Advanced Driver Assistance Systems, instrument cluster, what you see there when just giving the driver a bit of information about the engine, autonomous driving, and OTA updates. Those are generally the two functionalities for the OS that we are going to be making. The core modules, there is the bootloader and kernel, Linux kernel, and also we need to work with a bootloader. Remember, all this is still part of the RTOS, the real-time OS. So later onwards, I'll show you how to convert normal Linux kernel into an RTOS kernel. The powertrain and motor control, this is a very core function. Battery management system, infotainment and user UI, CAN bus communication, and OTA and cloud. Updates are going to be sent via OTA through the cloud. CAN bus, still I'm not sure whether I'll be working with the CAN bus. It's a time-tested bus communication system for the vehicle, but there are new models, new communication systems which are coming up, and I would want to give them a try. So my approach is going to be a hybrid approach. So yeah, I can add some bit of hybrid. So what does this mean? Hybrid is there's going to be an RTOS kernel and a normal Linux kernel. RTOS is going to be done, which will be handling the critical functions. I think RTOS is let me see, real-time OS, because right now let me check the kernel archives. I want to check what's the most recent kernel that we're working with right now. Should be 6.8, 6.14. So I think starting from 6.1, all Linux kernel came with RTOS built in, but you had to recompile or build a kernel again to enable RTOS. So this should be okay. RTOS will be handling mission control functions like motor control, which cannot stop at any one time. And then I also plan to let me just add here, Linux will be handling the infotainment plus UI, non-critical UI. So these are non-critical what are they called, functions. For the let me see, Tesla should be working with something. The Tesla should be a hybrid kind of OS. It should be, it's Linux kernel definitely. Android Auto, yeah, they should be running. That's just simple Linux. So the next part is now the component selection. For the main board, just as I said before, we'll be working with the NXP S32G2 board, and then of course the Raspberry Pi 4. This is a board designed specifically for, I think I need to find a way to make this play all the songs instead of having to keep moving back and forth. It's an automotive grade board, and it's an automotive grade computer, so that should just help us work on that. And then the microcontrollers for the motor, it's a VSC 75300, and for the battery, it's a BQ 76952. Networking. I'm working with the Marel 88Q2 um 88Q Q2 112. This is a very powerful network board. And finally, for the DC and AC inverter, open inverter 48 to 400. I think I should having a photo of this. Let me check. Open inverter. Open inverter. Not. I think should be this one. Open inverter. DC motor inverter. Probably this one. Yeah, I remember it's a software project. So building since sine wave since 2008. Yeah, it's an Arduino project, allows you to motor run inverter Modibus MQTT. It's a firmware replacement for the grow out. Interesting. Check on that later. And so this is for last time. So yeah, let me check up on how this one is going. It's almost done. Should be finished in time from now. But generally, that's what I'm working on at the moment. There's a lot of interest when it comes to automotive grade Linux. Because I've worked with it before, so I know its ins and outs. But my approach to this would be more of let me see, something from scratch, and that's the reason why I choose to use build root, because it gives the ability to choose exactly what components that you require, other than uh, having a desktop OS running on a very important software like a vehicle controller. What else is this AGL wiki? We can just quickly have a look at what they offer on the wiki. The roadmap, the Jira notes, connectivity, and all that stuff. We'll see whether we could get the software right now. Unless, well, that is running. We can check out the Tesla article. Transport engine. The first stage, version 4 to version 5, is Model S in 2015. Wow. Full self-driving came in 2018. So yeah, I think I'm gonna use a kind of display like this. Looks quite neat and straight to the point. That's the features that come with the OS. So games, Easter eggs, all that stuff. But yeah, that's pretty much it. This is source from Git. My approach would want something that I know what's happening inside. I don't want to download fully made OS, because when it comes to configuration, it's a pain. Start having to get to the developer, trying to find the correct the correct config. So that's why I wouldn't want to have something like this. But these guys have really done a very good job. I really give them credit where credit is due. But it's quite a big it's a big software, because once you see them using the repo tool, yeah, we are talking about a very large software base. Build a kernel, build bake, Did instruction on how to build a GL. Oh, there's also building a GL for the Raspberry Pi. It's interesting. Building a GL for the Renas Porter. It's a nice project actually. Seems to be a dead link though. So I don't know if anybody has worked on this before. So if you've worked on this before, then I think yeah, it's almost done actually. Links to Modic. So this does not exist, but there's something I wanted to see here actually. What is the Renaissance portal? Let's see. Renaissance portal. Yeah, CNX. Automotive system on chip for mid-range vehicle. Yeah, it's a graphics processing unit actually. Embedded cost systems. Oh, looks very, very good actually. Looks really, really good. Yeah, there's something that I'm gonna give. It's quite old, 2016. Well, I'm gonna give it a try. It's good to put some tabs on that. But yeah, this one should almost done right now. I want this to be done and see whether I could flash it to the Raspberry Pi and test it out. There's something that we forgot to do. Yeah, forgot to edit the configs files. I wanted to put Ethernet to come automatically, because this when you're building you can actually turn on options and turn off options which you don't need. Now, one very important one is networking. So it's good to turn it on such that when this new compilation starts, it just quickly goes online. So you can just pick it up via SSH without having to look for a display device. So as that happens, we can check up some news. There's something to check up right now on my phone when that is happening. Let me see. So while that does that, let me just check up some few things on my phone while that finishes. So it's almost done. It's almost done. Seems this one so this build seems to be taking more time than I expected. Let me see what I can do. So I think we might be having a problem here. With yeah, I think we might be having a problem here with the config file for the Raspberry Pi. So anyway, this video is going to be too long. So let me just try to get this sorted out offline, and then I'll just upload it in the next video. So yeah, that should so let me end the video here at this moment. Thank you so much, guys. Have a good afternoon, and then I'll catch you in the next video. So goodbye. Thank you so much for watching.